Okay, this one says calculate the volume of the solid obtained by revolving the region under the graph. I'm going to do this right now. I'm going to graph that, and that's going to be a root function, and that root function starts at -9. But I'm not saying this is a terribly accurate picture, but it's good enough for me. Right, so the region is under that. I got to find out what region they're talking about. But they say from 2 to 7. I'll write this over here, 2 to 7. So this is the region they're talking about over here. Now someone says, what are they doing? They're rotating that region about the x-axis. So this is the x-axis over here. They rotate it like this. And typically what we do here, we take a sliver, like this over here. And you got to start to realize if you take a sliver like this and you rotate it about the x-axis, it's going to form a disc like this. And basically what I'm doing is it's the volume of the disc. That's all I'm doing. All right, so that, sort of problematic, but I do know the differential. And I'll write that down for you. So what do you get over there? It's going to start at 2. We're going along the x-axis. It's going to stop at 7, and I got a differential dx. Right, I just accounted for this part of the picture over here. Now, what I got to do over here, I got to find the r of this. And the reason I got to do the area of this over here. And the area is going to be pi r squared. So it's going to be pi r squared. So what you're doing now is you're trying to figure out what the r is, and you're looking at the picture. The r is actually the y-coordinate. What's the y-coordinate? Well, it's right over here, and it's the root of x plus 9. Okay, the first step in doing problems like this is, are you able to get the integration? Right, are you able to do that? And if you are, that's good for you. That's the first step. The next step, can you do the integration? And it looks pretty easy to do. I'm going to pull a pi out. This is going to be 2 to 7. When you square the root, you get x plus 9 dx. Looks like a relatively simple problem. This is going to be pi. Then you can get x squared plus, whoops, made a mistake, x squared over 2 plus 9. Limit integration go from 2 to 7. Let's put this down. You can get pi, 49 halves, plus 9. You know what? I made a mistake here. I'm going to correct it. But the way I'm going to correct it is just erase it. I think I got excited or something and I made a mistake. So let's put this over here. Equals pi. This would be x squared over 2. I said 9. It's actually 9x. Limit integration 2 to 7. You can get pi. X squared is going to be 49 over 2. And 9 times 7 is 63. Minus pi. We're going to do 2 now. That's going to be 4 halves plus 18. I'm going to do the arithmetic. And pi is a common factor. So really what I'm doing is just 49 halves minus 4 halves, which is 45 halves. And then you get, let's see, 63 minus 18, which would be 45. Get my eraser, it doesn't look right. I can do the arithmetic. And what do you get there? You get pi. Certainly you get halves. And then what would it be? It'd be 1 plus 2, 3 times 45. 3 times 45 is 135. So 135 pi over 2 is the volume we just computed. So let me just point out what we're looking for on exams. We certainly are looking to see if you get the integration down. All right. Now, certainly a picture may help you do that. I'm hoping it does. I hope you're not just reading these things and trying to wing it. The other thing I want to do is, being able to do the integration and get the proper number. Mistakes do happen, though, and we're getting the proper number, which is 135 pi over 2. We're doing fine. Thank you.